Hello, Professor Marloes. What are we going to talk about today?
Hi, Ivan. I'd like to talk about ammonia and how we can measure it from space. Ammonia is a gas that's released, especially if you, from manure, so from cows and from fertilizer. And the problem with this is that it gets into the atmosphere, and it's then redistributed, so it lands somewhere else. Mm-hmm. And the problem at the moment is that in the Netherlands there's a lot of ammonia produced, also other nitrogen compounds, but let's mostly talk about ammonia now. Mm-hmm. And this also lands in nature reserves or areas with, let's say, sensitive nature. Because in those reserves there are plants that grow on nutrient poor sands. Mm-hmm. And if you add a lot of nitrogen, then other plants come in and outcompete them. And this is a problem. It's a big problem for the Netherlands because we're such a lot of people, such a lot of farms and cattle on a very small area. And that means that there is a lot of ammonia that's being transported around.
Okay. And how do we do that? How do we monitor?
There are several ways to monitor ammonia. So let's say traditionally it would be from stations. So you can measure it by sucking some of it into a small vial and then measuring it in the laboratory. Or you can do it with other optical methods on the ground. But the problem is that ammonia is very reactive. That means it's emitted, it's in the atmosphere, and then it reacts with the atmosphere. So let's say with sulfur dioxide or with nitrogen. There's always a lot of stuff in the atmosphere. It reacts, and then it forms aerosols, so small particles. And these aerosols are then transported away. But then the ammonia is gone. So that means that ammonia can only be measured rather close to the source, because otherwise you don't see it anymore. It also means that it's very variable in space, but also in time, because it disappears. And if you have only a few measuring stations, you will never get the full picture. Even in the Netherlands, we have quite a lot of measurement stations, but still it's not the whole picture. So you would prefer to have a satellite instrument that's always measuring, at least once a day, and that measured the whole of the Netherlands, so that we would be able to, or of Europe. It's not only a Dutch problem, but the problem is very severe here.
Okay. And what's the objective of this? Is to help making decisions, or?
Well, yes, certainly. A lot is being asked from people, particularly from farmers, because they are the major source of ammonia and other nitrogen compounds. And if we come with measures, well, not we, but if politicians come with measures, these should be really underpinned by good science, because it happens too often that that measures are being taken, which in the end do not really bring the results you want. Maybe there's only a small difference, or none at all, or you're making things worse. So you really need to, first of all, you really need to know where the largest sources are, where this nitrogen fluxes are going. So let's say the ammonia, this will also help to develop the science to understand what this nitrogen and what this ammonia is really doing, what's happening in the atmosphere, so that you can then go back and figure out what measures are really helpful and where. Because you can imagine that since this ammonia disappears rather quickly from the atmosphere, that farms around nature reserves might need more stringent measures than farms that are far further away. But that's not for me to decide. I'm just doing the science. So, but this is just to say that it's very important that the science is solid.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.